Go. Test. Very good. So this is a recording of practice test 1 for the TrANS group. Once again, if you see the word name, that is your name and today's date. If you have questions on today's date, you can look down here on the computer, 6/23/18. That would go in here. This would be your name. Station offsets. These will also be in the notes, but we're recording this to go through this together. So the easiest way to do this, sometimes it helps if you just draw it out. That's what I found to be the easiest. So right here is our alignment. And we have point A, that is 4325. So it's 4325, and we are 42 feet right. Looking up station. Point B, this is A. Point B is 4775 over here. This is point B, 4775 at 42 feet right, looking up station. And remember, the plus is just there because it tells us how many units of 100 feet there are. You just ignore the plus when it comes to the math. But the plus is in there just to tell you how many stations. It's really 4,325 feet away from the beginning of the project. That's where it's located. 4,325 feet from the starting point. But this right here is 43 plus 25 because it's 43 100-foot units plus another 25 units. Point C, 4325 over here. So this is C at 4325. And we are at 64 feet left. And finally, point D, which is not to scale, but we're going to put up here. This is point D. This is 4685 at 125 feet left. Does that make sense? Just looking at it graphically. Does anybody have any questions on this? Obviously, this is NTS, not to scale, but graphically, looking at this, does that make sense?
Yeah.
Good. So then, what is the distance between point A and B? We have the A and B right here. They're the same offset from the line, right? They're not sloped any different way. So my change in station is equal to what? 4775 minus 4325 is what? How much? 450. 450. My change in offset is how much? 0. So what's my distance? 450. If you wanted to take the calculator and take 450 squared plus 0 squared and take the square root of it, you'll get 450. A to C. A to C is this distance right here. If this is 64 feet and this is 42 feet, what's my distance?
06.
106 feet. So that's the distance from A to C, right?
Yes.
Now, the question is, what is the distance from C to D? C to D goes from here. Well, it should be a bent line. Let's try to do that again. It's a straight line. From C to D, right there. So right now, my change in offset, my change in station, when we want to do this, we'll move this over to here, the notes, not to scale. So from C to D, my change in station is equal to 4685 minus 43.25. So my change in station is equal to 360. My change in offset is equal to, I'm going from 64 to 125, so I subtract those because they're on the same side. My 64, I have a change in offset of 61. So right here, I have 360, and over here I have 61. Does everyone see that? Yes. So my distance is equal to the square root of change in station squared plus my change in offset squared, which equals 360 squared plus 61 squared equals square root 365.13. Yep. 365.13. So 365.13. Questions?
I must have done something.
It's okay. The whole point is learning what you did and fixing it. So, this is all assuming that the alignment is straight. If the alignment's on a curve, this doesn't count. This is all on a linear straight alignment. So when you're on a straight part of your alignment, you can do this. If you're on a curve, total difference. Are we on a straight line?
Disconnected. Connected.
We're on a straight line. So alignment is defined as a straight line with the bearing of north 65, 1848. So if I have 65 degrees, 18 minutes, 48 seconds, that is 65 plus 18 divided by what? 60? Yep. So I divide the minutes by 60, and I divide the seconds by what? 3,600. And that gives me 65 plus 18 divided by 60 plus 48 divided by 3,600 gives me a decimal angle of 65.31333 degrees. Or you can just use your calculator with the DEG button. 3 buttons down on your calculator. On the left side of your calculator, everybody has out of the Dollar Tree, there's the DEG symbol. So, if I want to have this bearing, which is 65.1848, I'd go to my calculator, I type 65.1848. I type in the degrees, minutes, seconds, so I say 65.1848. So I physically type that into this calculator. So I type in into the calculator, I type in 65.1848, and this is my DMS value. And then I press this button right here. Not too far. You press this button right here. That's a little button that says line DEG. And when I press that button, I get 65.31333. Now, on a future potential test, like next week, if I give you the decimal, I ask you go back to degrees, minutes, seconds, you can do one of two things. You can go long form, or if you're going to do it, you press the yellow button first, and then you press this right here, because that would activate what is above it. It says DMS. If you go second function, then press the DMS, it puts it back into 65 degrees, 18 minutes, 48 seconds. So, if I had a calculator, if for some reason you had a decimal value, let's say 128.61842 degrees, and you wanted to know what your DMS is, your degrees, minutes, seconds, then you're going to press second function, and then to DMS. So I'm typing in 128.61842, second function to DMS, and I get 128 degrees, 37 minutes, 06.3 seconds. So you have the ability to convert from degrees to DMS and from DMS to degrees. This is vital because just like having the ability to go from feet to inches and inches to feet, being able to transpose between two values comes in very handy.
Can you do it the long way?
Can I do it the long way? I sure can.
Is it really long?
No, it's not. Let's try it the long way. So, because it's always good to check your calculators to make sure you do it the long way. So, I want to know, does this really equal this? This is called a theorem, and we're going to proof this. Does this really equal this? Well, this right here is really, I forgot the 1 on this, by the way. So it should be 128. Is it 128 back here? Okay, here it is. So this right here, long form. So this is going to be 128 degrees plus 0.61842 degrees, correct? I just broke them up into two pieces. Then I know I have 60 minutes per degree. So my degrees will cancel. That leaves me with 128 degrees. So that gives me 128 degrees, 0.61842 times 60 gives me 37 minutes. So this gives me 37.1052 minutes.
That's multiplying 0.618.
60 times 0.6. So I take 128 degrees. I have 37 minutes plus 0.1052 minutes. I know I have 60 seconds per minute. Minutes will cancel. I'm left with 128 degrees, 37 minutes, wow. 6.3 seconds. So you can do it this way if you want, or if you remember your calculator, hot button, go straight to DMS. Up to you. I like the dollar calculators for a reason. It saves me time. But you need to be able to do it both ways. Absolutely. Any questions on that so far?
Yeah, no.
So, now that we know that, let's get back to the problem at hand. So we know this is 63.33, but this is still northeast, right?
Yes.
So let's draw this. And here's my line. I'm coming up this way, and this angle right here is north heading east, right? North heading east, that angle, and this is 65.31333 degrees. Does everybody see that? So what's my azimuth? My azimuth starts right here at 0, at north, and I head this way. So what's my azimuth? 65.31333 degrees. What's my Cartesian? My Cartesian starts here and heads this way, right? So my Cartesian is going to be 90 minus that one. So I take my 65.31333 negative plus 90. I get 24.68667.
So I have a question.
Sure, go ahead.
So if I put 65 degrees and 25 degrees, you're gonna mark that one wrong?
Yes, because that wasn't accurate enough. You lost your accuracy. So if I give it in degrees, minutes, seconds, and the reason for that is this. If I have 1 second, right? If I have 1 second, 0 degrees, 0 minutes, 0.1 seconds. How many decimal degrees is that? Let's put in 0.0001 degrees. That is actually 0.00027. So you have an accuracy out to 4 places with 1 degree, with 1 second. Good question.
You want them out to 5 places.
I go out to 5. But if you went out, I would have understood what you were talking about if you went out to 3 decimals. 3 is fine for this class. Questions? So that covers section 1. Any other questions on section 1? Section 2, scales. We did modify this one. Hold on a sec. We said this was 300 because the scales we have doesn't have a 400. You could have done the 400, and the way you would have done the 400, you would have physically measured this in inches and then multiplied by 400. That's all you had to do. So if I wanted to actually do this without having a scale, I just get a ruler, right? The scale allows me to direct read. If I just have a ruler right here, so if I just have a ruler, not a scale, I put the ruler up there and I physically measure that distance.
Might as well.
So if I actually go through and look at this right here, I'm measuring right now. This one right here would be a distance of 3 space 14/16 inch. And the second one is measuring right now to me to be 1 4/16. So 1 4/16 inch. Does everybody get that? Looking at that? Physically just measuring that line. Check it.
Yes.
Mind me.
Quarter,
Right. So this is 2 5/16. This is the next one. 2 5/16 inch. This one right here is 3 5/16 inch. And this one right here measured, that is 11/16. No,
14.
15/16. I got 15/16. So 15/16 of an inch. So That's how long physically on the paper. Thank you. So that's how physically long on the paper that line is that was printed on the one sheet I had for Malcolm's. So for this one right here, what's that? Question. We're going to get. So right now, that is if I took this ruler, I put this standard ruler, with 16 gradations in between the 4 and the 5. So this is broke up into 16ths. This is a quarter, half, 3/4, 5/8, etc. So this is broke up in 16ths between these lines. And that's if I physically place that over these lines. Those are the distances I came up with. Now, 3 and 14/16 really is 3 and 7/8 if I divide each the top and bottom by 2. 1 and 4/16 would really be 1 1/4. 1 1/4 inch. 2 and 5/16, nothing I can do with that. And 3 and 5/16 and 15/16, those are their least common denominators. So we have those going on. Now I take that number. If I have 1 inch is equal to 25 feet, I take 3 and I gotta get this to decimal. So 3 plus 7 divided by 8 is 3.875 inches. That's my decimal value. And then I multiply that by 25 feet per inch, and I would get a value of 96.875 feet. That's why I get longhand. If I took my scale, and what is a scale? Versus a ruler. An engineering scale looks like this. A bunch of different shapes and sizes to it. So you have 30 gradation, which really is 3. You have a 20 gradation, which is really 2, etc. But these are allow you to do a direct measurement. So for what we have, this is asking for 1 inch equals 25 feet, and our scale has a 25 on it. So I place the 25 on there, and then I read it directly. This isn't really 25, it's really 2.5, because you still have to multiply by 10. I put that on there, and I measure. Can I borrow it here, please? So I put that on there. And I directly measure 9.7. So I'm physically measuring 9.7, which then if I multiply it by 10 to get to 25, I would be at 97 with my direct measurement. Down here, 1 1/4. Decimal is 1.25. I'm going to take 1.25 times 50. I get 62.5 feet is what this measures out to directly. If I put my scale on that, I get 63 feet. I actually get 6.3, but because it's a 50 scale, I have to multiply by 10. Down here, this was 2.5. 2 plus 5 divided by 16 gives me 2.3125 inches. I multiply that by 300, and I get 69.375 feet. So this is how long it reads. If I put my scale on there, if I use the 3 scale, or what's on this R scale is 30. I place 30 on there, I would read 6.9, but I have 2 zeros, so I move that over 2 decimal places. I would have a direct read on my scale of 6.9, and then I add 2 zeros to that to give me 690. Down here, this is my architect scale. So here's 3.516, so 3 plus 5 divided by 16 gives me 3.3125 inches. That's how long the line is. I don't know what this other line is right there. We'll take that out. That wasn't on your sheet, was there? There wasn't two lines on there. So I must have put that in by mistake. So if this is a 1/4 inch equals a foot, then I times this by the bottom number. So I times this by 4. Times 4 equals, I should read 13.25 feet. Let's see if I do. Can I borrow, please?
Yeah.
So I take this right here, I put the Archie scale, I go to the, if I look at the Archie scale, so here's the Archie scales, and you see it's 3/16, 1/16, etc. You know you're in Archie scales. So I place the 0. Notice on the Archie scales, there's a 0 and then stuff that goes after. I put the 0 on it at a 1/4 inch. So I put the 0 on that line. And so right now I'm reading something past 13. So my 13, and then there's something past the 13 where I have it. So I'm reading 2, 4, 6, 8, 10, 12, if this was the Archie 1/4 scale. So architect, 1/4 inch scale. Let's look, see if we got. Nope. I don't see an Archie scale, so we'll just say it right here. So I put the 0 on right here at the end, and it goes past the 13. So then I slide my scale down so the 13 is at the end of the line. So right here I have it, 13 ends up right here. I slide that down to the 13, I read a 1/4 on the other end. So I slide that down and it goes to a 1/4. So that's 13.25 feet. That's how I directly read. On this right here, this is 15/16. So 15 divided by 16 gives me a decimal value of 0.9375 inches. If I have 1/8 equals 1 inch, I divide by the 8. So 0.9375 divided by 8. Whoops, I'm sorry, multiply by 8. So 0.9375 times 8 is 7.5. So 7.5 feet. If I put my 8th scale on here, so I go to the 8th scale, I put it at the end of the line, put 0 at the end. It's 7, it's past the 7, so I slide the 7 down, and that tells me I'm at 7.5. And that's what I read on here.
Steve?
Yes.
When you are, for instance, if the fraction was a 5/23, 5/23,
You will never have a 5/23. But here's the answer to your question.
a 2,
No, here. I know what you're trying to say.
yeah,
So right here, and let's snippet this. So the question is how to divide by a fraction. So
I know you inverse,
right here, this is 1/8, right?
right?
So I have 1/8 of an inch.
What if it's 5/8?
I don't know. We have 1/8 of an inch equals 1 foot, correct?
Okay,
If I want to get this to 1 on both sides, if I want to get 1 to both sides, what do I have to multiply by? I have to multiply by 8/1 on both sides, right?
okay,
So if I multiply by 8/1 on this, these cancel, I have 1 inch equals 8 feet. So under your scenario that you're trying to ask is what if I have 2/5 of an inch equals a foot, right?
okay,
So I multiply each side by the inverse of that, 5 over 2. I multiply this side by 5 over 2. And this is the easiest way to divide fractions. You multiply by the inverse. So these cancel. All right, left with 1 inch equals 5 over 2 feet. So the easiest way to divide a fraction, if you have in the future, which you will have, if I have 5 divided by 3/4, right?
Yeah.
So if I have the value of 5, let's do this. 5/8. So I have 5/8. The quantity 5/8 divided by 3/4, right? 5/8 divided by 3/4. That's really 5 over 8 times 4 over 3, which gives me 20 over 3 times 8 is 24, which becomes 10 over 12, which you can divide another 2, which becomes 5 over 6. So 3/4 of 5/8 is 5/6.
When you multiply it by the denominator, you get a number, and then what do you do with the numerator after it's inversed? Do you multiply?
When you inverse this, right?
Yeah.
Then what I did, I multiplied these two together,
Yeah.
divided by these two together. So that became 20. This became 24.
And if the 5/8 was a whole number, you multiply that by the inverse denominator, and then what happens to the numerator?
Same thing. So if we have 8 divided by 1/2, right?
Yeah.
8 divided by 1/2, which means what?
8 times.
I'm moving it back together, so I have 8 times 2 over 1, which is equal to 16. So you take fractional division, you take the denominator, you inverse it and multiply it.
Okay, so you multiply 8 times 2 divided by
1.
the bottom one.
Right, divide by 1.
Okay,
So it's 16 divided by 1, which is equal to 16.
okay, so if that was 5/8, you flip it up, you do 8 times 8 divided by 5.
Correct.
Okay, that's where I was missing.
Absolutely.
Cool.
Surveying. This is stuff you guys should have had cold. So, how many feet are in a mile? 5280. 5,280 feet in a mile. It's a number you need to have cold. How many square feet are there in 1 acre? 43,560 square feet in 1 acre. How many square miles are there in a standard township? A standard township is what?
6 by 6.
So a standard township is 6 miles by 6 miles, correct?
Uh-huh.
Which gives me 36 square miles. So 6 miles by 6 miles is 36 square miles. One section inside that township is how big? There's 36 sections, right? Inside a township. One section is how big? 1 mile by 1 mile,
Disconnected.
right?
Connected.
So you have 1 mile by 1 mile. 1 square mile. If we have 1 mile by 1 mile, right? That is 5,280 feet by 5,280 feet, right?
Yeah.
And this is where the funky math comes in of the English system. That is 27,878, 400 feet squared. Square feet. So you have that many square feet. How many square feet are there in an acre? There's 43,560 square feet equals 1 acre. So if I divide by 43,560, I end up with 640 acres in a section. So there's 640 acres in a section. This is where some of these terms will come into play now for you. If I divide that section into quarters, right? 1/4 is going to be how many acres? Divide that by 4. 1/4 is 160 acres. So 1/4 section is 160 acres by definition. If I divide that into another quarter, right here, one section right here is how much? That is 40 acres. If you hear the term on those cowboy movies, oh, we're moving them to the back 40. That's where this term came in. That was the back 40 acres because everything was broken up into 40-acre units when we were selling them off years ago. You break up that 40 acres into quarters. What do you get? For one section here is how much? 10 acres. In a lot of municipalities around here, before you get in, not municipalities, a lot of countryside, a lot of township rules, they'll have rules of minimum lot sizes. What is the minimum lot size for most houses? 5 acres. It's 5 acres is the minimum lot size for a parcel to be broken out into when you get into the country. And that's where that minimum 5 acres comes from. It's 1/4 of a quarter of a quarter of a half. Or 1/2 of a quarter of a quarter of a quarter of a section. So that's where all those terms come from. So right here, asking to highlight here, here's a map of our sections. There's our 4th principal meridian, our east-west baseline. These are 2 things that define the state of Wisconsin survey-wise. There's our east-west baseline and our 4th principal meridian. The 2 lines that define our section, all of our coordinates in the state of Wisconsin, is the 4th principal meridian and the east-west baseline. Where's Township 4 North, Range 20 East? Township 4 North, 1, 2, 3, 4, Range 20 East, right here.
Racine, right?
In Racine.
Yeah.
I've been right there. Just fill that in. Right, Joey? So, next one. So, I want Township 8 North. 1, 2, 3, 4, 5, 6, 7, 8. Right there. But I want to go, say that again?
Corner from the G.
Yep, so here's 1 west, 2 west, 3 west, and right here.
Oh, yeah.
Right there it is. So, yeah, but if I try to erase this, I want to erase the whole thing. Yep.
Oh, wow.
Cool, but not cool.
Yeah. Now we'll get this right. So, 1, 2, 3, 4, right there. So those are the two spots. What does the POB refer to for property description? Point of beginning. That's the point of beginning on your property. You've gone from a section corner, you've routed your way around to the first point on your property. That's the first point on your property as defined by that lot survey. POB, point of beginning. Azimuth Cartesian angles. So, azimuth Cartesian angles. We have that angle right there. My Cartesian angle starts right here and goes which way? Around to here. So that's 90, 180, plus another 20. My Cartesian angle is 200. My azimuth starts right here at 0. Goes 90, 180, and then this angle right here is going to be what? 70. So 90, 180 plus another 70 is 250. My bearing. So go ahead. Question? Oh, I did. Thank you.
We understand.
No, I don't want to confuse people. So that's 250 right there. What about my bearing? My primary axis is which side, north or south? I'm primary south, heading which direction, east or west? I'm heading to the west. So I'm south, heading to the west, what angle? 70 degrees. So I'm south, 70 degrees west.
Bang. Hey.
Moisture contents.
Numbers. Numbers.
So, my empty tare is 6.2 pounds. My tare filled with water only is equal to 64.9 pounds, right?
Yes.
So my water only is going to be equal to 58.7 pounds. My unit weight of water is equal to what? 62.4 pounds per cubic foot, correct?
What?
Unit weight, I know, surprising.
Oh.
That's not on there. So my volume of my tare in cubic feet is equal to what? My water divided by my unit weight, which gives me 0.94.
Nice.
So my tare plus wet soil is equal to 135. My tare plus dry soil is equal to 127. Now, what I'm going to do, I'm going to highlight these two and highlight these two so I know those are the numbers I have to type in later on. And then what I do in Excel, I always change these to blue when they're equations, so I know I'm not touching those later on when I open up my Excel sheets. It's just the way I organize my Excel sheets. You don't have to do it this way. It's just a personal preference. So wet soil, how many pounds of wet soil is there? That minus the empty tare. My dry soil is going to equal my dry soil minus my empty tare. So then, weight of water in the soil would equal that minus that. So I have 8 pounds of water. My moisture content is equal to weight of water divided by my weight of solids. My dry soil is my weight of solids. My wet soil is my weight total. So my moisture content is going to be plus the weight of water. So this right here is weight of water if you're using the 3-phase diagram. So my moisture content is weight of water divided by my weight of solids, which is 0.662. Right click, format cells, my percentage. Well, let's do this. Format cells, percentage, 1 decimal place, which is 6.6%. So therefore, my unit weight total, right? My unit weight total is going to equal my weight total divided by my volume total. So my unit weight total is my wet soil divided by my volume of my tare. So I get that in PCF, pounds per cubic foot. I'm just going to format this, format cells, number, 1 decimal place. And once again, these are all blue.
So 137 would be okay.
Yeah, 137 would have been fine. I would like to have seen it in 2 decimal places, but that's fine. The specific gravity is going to equal my unit weight total. My unit weight total divided by what? 62.4. Which is the unit weight of water. So my specific gravity is that divided by 62.4, and you get 2.91. Format cells, number, 3 decimal places typically on specific gravities. And my dry unit weight is equal to my weight solids divided by my volume total, which is my dry soil divided by my volume of my tare. And so this right here, format cells, number, 1 decimal place. Once again, these are blue. So there's my answers for all this. How many people got that? So let's go back and look at the rest of the test. So on this side, we have different numbers. Let's type those in. So my empty tare is 3.5. My volume of mold is given at, so in the sample 2, my volume of mold is given at 0.4. So my volume of mold is 0.4. So that became 0.4. And this stopped being, and this is back being black. So 0.4. My weight filled with wet soil is 59.9. My weight filled with dry soil is 54.2. And so there's all my answers.
Oh, that's cool. Scooty.
That's the advantage of the spreadsheet. So,
You're putting this in our notes too, right?
yep. So you have all that, well, I'm recording this.
Oh, okay.
So you have all this going in. Any questions on that?
Can I see those answers?
You sure can. Did anybody get these? Okay. So, that explains that one. Section 6, geotechnical. What is the plastic limit? Plastic limit is the moisture content.
Yeah.
It's the moisture content at which a material starts acting more like a plastic moldable. It has moldability to it, right? versus a solid, where it's more crumbly. So you're developing plasticity to your sample versus having it all solids and it's crumbling off into pieces and parts. Liquid limit. It's the moisture content. The critical word is moisture content at which a material starts acting more like a liquid than a solid. Now, the tests that we do to get these are called the Atterberg tests. So the two tests here is the Atterberg tests. So those are the tests that we use to get those two samples. So soil samples, we looked at soil samples out here. Describe how soil samples are obtained using a split spoon, include what numbers means on the report. So how do you get a split spoon? We auger down to a certain depth, we slide down the split spoon, and then we hammer for 6 inches. We hammer the split spoon for counting the number of blows to go each 6 inches for a total of 18 inches. So we have 4, 9, and 11. That was 4 blows for the first 6 inches, 9 blows for the next 6 inches. For those counting, 11 for the next 6 inches. In industry, you will need to know this for the next test. In industry, we have something called a blow count. A blow count. The blow count includes the last 2 numbers. It doesn't include the first number. It only includes the last 2 numbers. So my blow count for this sample would be 20. The reason we don't use the first sample is typically that's disturbed by going down. We want something called in situ values. The term is in situ, means in its environment. So we don't want it disturbed while we're getting those measurements. We want in situ, in its environment. That's what we were trying to get when we do those blow counts.
So the process, they drill a hole.
They auger the hole down.
How deep?
As wherever level, we had different auger depths back there.
Okay. So
And then you take samples at different auger depths.
Okay.
So those are all predetermined by the engineer. So aggregate gradations. For those of you playing around at home, right here is the sieves, and here is my cumulative weight retained, total cumulative weight. If you notice right here, there's a plus right here. We in Excel, if you're using Excel, can't handle the plus, because if you try to take plus this, plus 5, it tells you, hey, you don't have any value, because it doesn't recognize the letters. If there's letters in it, there's 2 things. There's letters in Excel, and there's numbers in Excel. Notice letters are left justified, numbers are right justified. If you have letters and numbers, AD15, it treats it as a alpha. Those are alphanumeric values. It treats it as an alpha. It will not add an alpha. It only adds a numeric. So the quickest way to do that is you just highlight these. You come over to find and select, and you replace. You replace what? I'm going to replace the dollar symbol. And you say replace all. And now the dollar symbol is gone. So now we can say plus this, plus 5, and it will add it. So now it's a numeric. So I want the percent retained. I'm not expecting you to know Excel. This is just easier for me to do this quickly. So percent retained is what? It's going to be plus my cumulative weight divided by my pan, correct? Now, For those at home trying to do this Excel, you gotta lock down these cell symbols with dollar symbols. And what that does is it makes sure that you divide each one of these by the pan. So when you copy that down, there's all your values for your retained. Now this is only retained, it's not percent retained. If I want percent retained, what do I have to do? I have to multiply this by 100 for each one, right? Or I just say format cells, number, and I go percentage. I say okay, and there's my percent retained for each one. My percent passing, and like I said, I'm not expecting you to know how to do this on Excel, but I'm expecting you to be able to take 0, divide by 52, and get 0%. Take 0, divide by 52, get 0%. Take 6.8, divide by 52, and get 13.1%. Take 14.5, divide by 52, get 27. Take 14.9, divide by 52, get 27.9. Take 14.9, divide by 52, get 28.7. Take 15.7, divide by 52, get 30.2. Take 37.5, divide by 52, get 72.1. Take 51.7, divide by 52, get 99.4, and 100. I'm expecting you to be able to do that.
Okay, so
Go ahead.
the pan is the total weight?
Yes, that's your total weight.
I thought like
If you pour everything into your pan,
yeah,
what's going to be there?
the pan is the entire sieve?
Right, all the weight.
Oh, okay. I thought pan was the tininess that got collected on the bottom.
That's the individual differential. But you're dumping everything into the bowl, right?
Yeah.
So once you dump the pan in there, that's the entire weight. My percent passing is this. And so if I have 13.1% retained, I have 86.9% passing. 100 minus this gives me that. So there's my values for that section. Now, what's so special about the number 4? Everything above this, right? Everything that's on the number 4 or above is called a what? A gravel. Everything that passes through the number 4 is called a what? A sand, silt, or clay. You don't know, but it's not a gravel. A 200, right? If it's caught on the 200, it's a what? If it's passed through the number 4, but it got caught on the 200, it's a sand. Exactly. Everything that passes through the 200 is a fine. It could be a silt or a clay. Correct.
Or fine.
So, if we were to look, I look at the USCS, here's a nice easy one. Not that one. So there's a system out there called the Unified Soil Classification System. And this classifies what a material is. It's a way we all get on the same game page with regards to understanding what a material is. We have letter designations. G stands for gravel. S stands for sand. M stands for silt. C stands for clay. O stands for organic. M for silt because we had already used S for sand. Then, secondary letter is poorly graded, well graded, high plasticity, low plasticity. Plasticity is your moisture range. If you have a high plasticity, you have a large difference between the liquid limit and the plastic limit. Right here is how we go about classifying materials. So let's go look at our chart right here. And we're going to take this. And let's classify this material that we have right here. I'm going to copy this and go over to this chart and say paste. And let's classify this. So this is broken up into a series of questions. So the first question right here is this. On the number 200, so this is so on the number 200 sieve, so number 200, do you have more than 50% retained, or do you have more than 50% that passes? On our sieve, number 200, do we have more retained or more that passes? We have more retained. So this area right here is out. We will not classify those. Then we go to the next one. Right here, this is the number 4. Do we have more than 50% over here, or do we have more than 50% down here? More than 50% retained or more than 50% pass? For my number 4. I have more than 50% that passes, correct?
Yes.
So this is good, this is out. So all these are no longer counted. So then I have a question. Right here. Do I have clean fines? Or do I have more than 12% fines? How much passed from here to here? How many fines did I have? I had 0.6% fines, right? So I have less than 12% fines.
Anything caught on a 200 is a fine?
Anything past the 200.
Disconnected.
This is
Connected.
percent passed,
Oh, okay, my bad.
right? So that really should be a different color, even though it's a 200 sieve definition. We'll turn this red because it's asking a different question, even though it's still dealing with the 200 sieve. So all that is gone. So we're up here. This is not true, so this is out. And now, are we well graded or poorly graded? Well, if we look at that, we got 13 and we're at 27, 28, 30, and then we jump to 72 and then we jump to 99. So we didn't really go one size, did we? We have a nice gradation around the sand level. We don't have any one spot. If we look, our sands are doing this instead of this. So we're more like this, going from 30 to 72 to 99, right? We have a nice gradation in there. So we're going to be a well-graded sand. So this material is a SW by definition. So this material that you deal with would be an SW, which stands for a well-graded sand. If it was more of one type, it would be a SP, a poorly graded sand. So, any questions on that?
Steve,
Go ahead.
so when it goes up gradually, it's well graded. When it goes up like exponentially and then cuts off, it's poorly graded.
Correct.
Okay.
And when it goes up in a singular line, it's uniformly graded. Means it's all the same type. So how many openings are there per linear inch on number 40 sieve? 40, right? There's 40 openings per linear inch, which means how many openings are there per square inch? 40 times 40, which equals 1,600. What does NMSA stand for? Nominal maximum size aggregate.
What?
Nominal maximum size aggregate. What is your largest rock? On our example over here, right here, what's our NMSA for this material?
The nominal size is the 3
3 quarters.
Yeah.
It'd be a 3/4.
Are we going by the 5% rule, or are we just going?
We're
by
going
the
by
largest?
whichever one has the largest rock.
Okay.
That would also meet the 5% rule.
Cool.
So, what is the divine sands and gravels? This would be a number 4. What's the divine between silts and sands? Number 200. Anything passing the number 200 is typically called what? Fines. It was in the question right above it. There's terms that you need to know.
What is ashito?
Exactly. AASHTO, AASHTO, American Association of State Highway Transportation Officials.
Dang.
ASTM, American Society of Testing Materials. ACI, American Concrete Institute.
Whoa.
We have DOT, Department of Transportation.
Yeah.
These are terms that you need to be familiar with. Terms that you need to know. Yes? Question?
No, this one's.
Okay. So, also, know the terms. PCC stands for Portland Cement Concrete. AC stands for what? Asphalt concrete. PCC pipe is what? Portland Cement Concrete pipe.
Pouring.
Portland Cement Concrete pipe.
Portland.
RCP
Exactly what I was gonna say.
is what? Reinforced concrete pipe. Reinforced concrete pipe, RCP. CMP stands for what? Corrugated metal pipe. Corrugated metal pipe. That's the rib pipe that you see in driveway culverts everywhere.
These definitions, will I be able to find them?
Yeah, you can Google all of them.
Okay.
So, HDPE stands for what? High density polyethylene pipe. That's the plastic pipe that you see on the side of the road out here. The blue stuff. There's other pieces to it, a little higher grades, but these are what you see coming in. These are terms that you need to be familiar with.
The answer for 7-5, that was 3/4.
What is the MSA for this aggregate? It would have been 3/4. Yep, 3/4. Locations. I was expecting a little bit better effort on this one.
I never even got to it.
Shit, man.
So, on this one, for those that got to it, I was expecting a little bit better effort. This dealt with our 2-point referencing. So if you take your scale and point C is located 80 feet from point A, you take your scale, you put your scale up here, right? You mark off right here, this is 80 feet. 1 inch equals 20 feet. So if I'm at 1 inch equals 20 feet, then this distance on my scale would have been what? 4 inches. So I'm going to put a mark right here at 4 inches. And then I rotate this around a little bit. Okay, I only want this. And I put another mark right here at 4 inches. I put another mark at 4 inches. And eventually I get a line arc that looks like that at 4 inches.
Okay.
Right?
Yeah.
Actually, my 4 inches would have been more out on the scale of my paper, somewhere out through here. So that would have been my 4 inches, actually, on my paper. But then I bring this down here and and if I'm 60 feet away from point B, how far am I going to be? So 60 feet,
3 inches.
60 feet would be 3 inches, right? And I mark my 3 inches from point B. Where are the two possible places point C could be? Point C could be right here or right there. Those are the two potential spots that point C could exist in space. That's your 2-point reference. And you just draw an arc 4 inches from point A, you draw an arc 3 inches from point B, and where those intersect, those are your two potential places for point C. This is why we need a 3-point reference in the field. If we're going to reference anything, we need a 3-point reference in the field in order to get the exact location. So I need a third point, point D right here, so that I would know whether I'm here or whether I'm here. Does that make sense?
Yeah.
Off of everything that you physically did this week, can you see that now? You guys have done this in the field. On the back of explain diagram how you lay out wall with a right angle corner using just 2 tapes. I don't know, what would we use? Oh yeah, the 3, 4, 5 golden triangle. Duh. I lay out a line here at 30 feet, and then I take this tape right here, and I go out 40 feet, and I take this tape right here, and I go out 50 feet, and where they intersect would be exactly at a right angle. 3, 4, 5 triangle. You guys have physically done this. It's just a matter of articulating what you know. How would you check your 3, 4, 5 triangle? 5, 12, 13. And then when I'm done, I'm going to check this with the 5, 12, 13. Now, since I'm at 30, 40, and 50, I could go 10, 24, 26, because that's a scalar of 2. I could scale this up and go as scalar of 2 if I wanted. And so I could come out here and say, okay, this right here is 10 feet over. This side right over here is 24. And I check to make sure this is 26 to verify that I'm at a right angle. Plan sets. What signs are at location 14 plus 50? Well, let's get back down to the other ones. 8, 4, these right here. What is the section corner at 89 plus 71? So if we look at these plan sets, 89 plus 71 would have been right here. And what section corner is that? That's Township 3 North, Range 22 East, the east corner of 29 or the west corner of 28. So this is my section corner. So what section corner is that? That is Township 3 North, Range 22 East, east corner of 29, or the west corner of 28. Because if we look, here is 29, here's 28, here's 29, here's 28. And so we have all these section corners. So boom, northwest, north, northeast of 29, east of 29, southeast of 29, south of 29, southwest of 29, and west of 29.
I see.
So this is southeast, this is the east corner of 29. Or I have the northwest of 28, the north of 28, the northeast of 28, the east of 28, the southeast of 28, the south of 28, the southwest of 28, or the west of 28.
Cool. I see what you're going there.
So, what is the bearing of the alignment between 92 and 112? The bearing between 92 and 112 is what? North, 0 degrees, 31 minutes, 43 seconds west. So right here's my bearing of that alignment. North, 0 degrees, 31 minutes, 43 seconds west. Between those two stations, between that station and that station, we have a linear stretch of road, and it's at that bearing. So right here is your plan set, and the question asks, on the plan set, what signs are at station 1450 right? So, at 1450, 14 plus 50 would put us right here. This is 13 plus 00, 14 plus 50, this would be 25, 50, 75, 15 plus 00. So right here at 1450 to the right, which is looking up station,
Looking directly north.
there is nothing, right? How about that?
Yeah.
There's nothing. There's no signs. If this would have been to the left,
Yeah.
so if there are no signs, 14 plus 50 to the right, but if we looked at 1450 to the left, then you'd have an M2-1 and an M1-5A. And you'd have a J1-1. So those would be your three signs. I'm not even quite sure what the third sign is. So it's an M2-1 and M1-5A, a junction sign with the county trunk highway sign. That's to the looking up station to the left is right here.
What is the 1-8 and 1-9 number?
1-9, this is the sign designation so they can keep track of the signs. So when we go to our quantity tables, down here, right here, we can keep track of what 1-8 and 1-9 are.
Speed limit?
So you know the type of signs, the wood post it has, etc.
Oh, geez.
So you know what size and everything that you're dealing with.
Okay. The to scale specs or whatever.
Yeah. So what station is the proposed W14-3 sign no passing to be located?
Station
Um,
28.
Maybe before paint.
Station 28.
Yeah, I want to get to it.
Oh, down there.
I've lost it.
Station-
There we go. And we need sheet 67.
I'm not seeing the W14. Oh, there it is.
Right here. Here's the 1-17. So if at 117, we're at right around 28 plus 00. So that 1-17 no passing zone, W14-3, that's asking for, that no passing zone is located at 28 plus 00 to the left. Then we get into these. And these, we should have been able to close our eyes and do by now. But if we're not, that's okay. There's practice to do between now and then. Remember, a mistake is just a learning opportunity. Some of you have far more learning opportunities on the test than you should have had. But that's okay. They're learning opportunities. So, let's run through these real quick.
Hey, Steve, real quick, what, we going YouTube, what stuff we gonna do?
So, okay, a water truck started with 4,000 gallons. At the end of the day, 850 remained. How many gallons were used during the day? So we started out with 4,000. And at the end of the day, we had 850, right? How many gallons were used? 3,150.
Woo!
A contractor had 3 pieces of rebar measured 5.2, 4.8, and 7.5 respectively. They're all laid into it. How long would it measure? Well, if we had 5.2, we had 4.8, and we had 7.5, that means we're at 16.15, which is really then, if we add this up, 17.3. So 17 feet 3 inches. Decimal feet is 17.25. Inches would have been this times 12 plus this, or 207 inches. The percent of 0.5428 is 54.82%. Moving it back 2 decimal places, 54.82%. What is the decimal value of 48%? Decimal value is 0.48. What is the decimal value of 0.48%? That would be 0.0048. That's the decimal value of 0.48%. Wants another container empty, blah, blah, blah. So we have 5 pounds empty. We have 36.2 filled with water. How much water is there? There's 31.2. So my volume divided by 62.4 tells me I'm at 0.5 cubic feet of volume. So the volume of the containers, volume of the water is 0.5, and we could completely fill the container, then it would be 0.5 also. Pile of lumber contains 50 boards, 30 boards, 12 boards, and 20. So we got 50 boards, 50 boards, 30 boards, and 20 boards. These are 10 feet long, 12 feet long, and 16 feet long. How many pieces of lumber do I have? I have 100. And how many linear feet do I have? I copy those down. Control C, Control V. I have 1180. So the total linear feet would be 1180. If I have 50 boards that are 10 feet long, that's 500 linear feet. I have 30 boards that are 12 feet long, that's 360 feet. I have 20 boards that are 16 feet long, that's 320, for a total of 1180 linear feet. So if I have 80 pounds of aggregate dumped into a 3/4 inch sieve, 8 pounds remain. So I have 8 pounds remain. My pan is 80. What is my percent retained? Plus 8 divided by 80, which is 0.1, which is 10%. And then if that's true, what's passing? 90%. Define sieve between gravels and sands. Number 4. Define sieves between sands and fines. Number 200. Liquid fertilizer. If we have 8 ounces and 40 ounces, what's the total number of ounces? 48. 40 plus 8. And what is the concentrate? So we have 8 to 40, which if I divide that by 8, and I divide this by 8, I get 1 to 5. So I have 1 to 5 concentrate. If I would have asked you water to fertilizer concentrate, that would have been 5 to 1. If I asked you fertilizer to water concentrate, that ratio is 1 to 5. Once again, another one of these. So 103.6 plus 103.6 minus 10 gives me 93.6. That divided by 62.4 gives me 1.5 cubic feet. is the volume of the container. And if I filled that up with concrete, I'd take 1.5 times 150. And then don't forget to add in the weight of the container. So 1.5 times 150. 150 is the unit weight of the concrete. So this is the concrete in the container. So the concrete plus the tear would equal what? So the concrete plus the tear is going to equal 225 plus the weight of the tear, which was 10. So the tear plus the concrete is 235. Concrete slab is plus 17 plus 10 divided by 12. And we're plus 16 plus 2 divided by 12. And we're plus 4 divided by 12. The surface area is that times that. So that's square feet is my surface area. My cubic feet is going to be my surface area times my depth, 96. And if concrete weighs 150 pounds, what's my weight? So my weight is equal to my volume times the unit weight, which is 150. I get 14,415. A finished grade 2 embankment is designed at a 4-to-1 slope, extends 12 feet horizontally past the edge. How far below are we? Anybody? 3 feet. Once again, 60 pounds of material dumped on a half-inch sieve, 20% passes. How many pounds of material remain on the half-inch sieve? So if 20% passed, how many remained? 80%. So if 80% retained, we take plus 60 pounds times 0.8, and we get 48 pounds. Thus, the answers to all the questions. Any questions? Go on to.